Okay, so let's do the okay. So yeah, given that log 5 base a all squared minus 4 log 5 base a plus 3 equals to 0, find the values of a, find the possible values of a. So this is quite interesting. Now anytime you come across logarithm question where not logarithm question per se, but I come across an equation where what you are seeing can be seen again. Let me put it this way. Whatever you are seeing can be seen again. It's always best to do a variable representation to make the work easier to manipulate. It's not compulsory at all, but it's always best. And also, I should say that coming across log 5 base a raised to the power 2 is not the same as writing log 5 base a whole squared. So this and this, they are not the same. Okay?
Yeah.
They are not the same. This will result into 2 log 5 base a, and this will result into log 5 base a times log 5 base a. These are not the same thing. Okay?
Yeah. Yes, sir.
Okay, good. So you should keep it in mind. So like I was saying, since I can see log 5 base a over here, and at the same time I can see log 5 base a, I can make a variable represent everything. So I can let a variable, which variable should we use?
Why?
So let's y equals to log 5 base a. So if that's the case, then I can rewrite the question as y squared minus 4y plus 3 equal to 0. Then we can solve the quadratic equation. So I know this is paper 1, but like I said, I know you can do a quadratic equation. So why do we waste the time? Let's use the calculator to solve it so that you can solve a lot of questions. And
So it's 3 and 1.
okay, so y equal to 3. So y minus 3, y
And
plus.
why?
Okay, 3 and 1, right?
Why? Yeah.
So y equals to 3 and y equals to 1. So from here, because we did variable representation, I can now say that therefore log 5 base a is equal to 3 and log 5 base a equals to 1. So we now have to change from logarithm to exponential. Remember how to do that?
Yes.
Okay, so what will this one give you?
A raised to the power 3 is equal to 5.
A raised to the power 3 equals to 5. And this one, a raised to the power 1 equals to 5. A raised to the power 1 is the same as a. So we've gotten the answer to this one. We are good to go.
Yeah.
Now, the next thing to do is to get rid of the cube over there. Just like if you've got a squared equals to 4, what would you do to get rid of the square?
Square root.
Take square root. So if this is cube, then I should take cubic root. So taking cubic root of this one and taking cubic root of this one, we can say that 8 equals to the cubic root of 5.
5.
You get?
Yeah.
Okay. So let's try to move on to something else.
To say after that, you don't test whether it's correct.
Well, at times you would have to
Like which one?
come again.
It's like won't you test like which one best fits?
Oh no. Once all the numbers are positive, you don't really need to do the testing. Because of the domain of logarithm, it doesn't really take negatives like that. So, but let's check and see. So we've got log a 5 base a. Or let me square all this. So this one squared minus 4 log. Again, the base is a, and this is 5 plus 3. So if you have to test whatever answer we put into for a, we should get 0. So calc when a is equal to, we got the first one to be a to be equal to 5. So when a equals to 5, the answer is 0. So we are correct. Calc again. When a is equal to, oh, this cubic root, not fifth root. So cubic root of 5. That is also 0. So both answers are correct. You don't really need to check if they are all positive. You are not really going to face with a lot of issues. Well, I should be careful of what I'm saying because you can get an answer to be positive. Let's say that this is log a minus 10, and we got a to be equal to 5. A will not satisfy this equation because if you put 5 over there, you're going to get log negative 5. So yeah, so you can just make a quick check by looking at the question. If you substitute the value, will you get a negative number inside the log, or you get a negative number as the base of the log? So we look at it before we go. In this particular question, all the answers we got were positive, and the base was what's the name? The variable. So we don't really need to check. It's going to waste our time. We good?
Yes, sir.
Okay, so that is that for that question. And there's another question. Log x base 3 plus log x base 9 equal to 12. Solving this question shouldn't be that challenging. Another thing, again, we should notice the bases. The bases are different. So the first one, the base is 3, and the next one, the base is
Right.
9. So I would always advise you change to the smaller base. Okay, it's not compulsory though. You can change to any base at all, but I would always advise you change to the smaller base. Maybe matter of preference. So I'm going to change the log x base 9 to base 3. So this would give you everything to be this. And like I said, you can look at this as a fraction. So we've got log x base 9. The x is the numerator, the 9 is the denominator. So this is a formal fraction x over log 9. Then we introduce our new base. So the base is 3. So this is simple like that. So this is log x over log 9. Then we introduce our new base. This is equal to 12. Okay?
Yeah.
Log 9 base 3 is actually 2. So I can write this one as log x base 3 plus log x base 3 over 2 equal to 12. Again, the advice I gave you, not so compulsory, but anytime you see things of the same kind, you can do verbal representation. It's not compulsory though. I can literally solve it without a verbal representation. But to make your work look neater and clean, I would advise you do something like that. So with this one, I can let m be. So let's the variable m be equal to log x base 3. This may waste your time a little bit, but I feel it's safer. So let's go with this one. So this will be m plus m over 2 equals to 12. Now it's clear what you can do over here. Multiply everything by 2. That's 2m plus m equals to 24. Then 3m equals to 24. What will be m? I think m should be. Okay, so we can do the back substitution. So we can say that log x base 3 equals to 8, where 3 raised to the power 8 equals to x. So you can leave your answer this way. There's a very big number, so you don't really need to. You don't really need to type on the calculator. I bet if I type on the calculator, it's going to give me a very huge number. Oh, it's not that huge. So 6,561. So that is the value of x. So if you like, you can check again. Like I said, this is positive, so it doesn't really go against the domain of logarithm. We are good to go. Now, the next thing too is this question. With this one, there are things that you need to note. The first advice I would give you when you come across questions of this nature would be, first, make sure there is no number in front of the logarithm. So, right. So make sure there is no number in front of the logarithm. In this case, you can see there's 2 in front of the logarithm. It's not a good thing for us at all. So you make sure there is no number in front of the logarithm. The next one would be to isolate all the logarithms. Put all the logarithms at one side of the equation. And the follow-up with that, we'll go with the flow. So the first thing is to make sure there's no variable or there's no number in front of the logarithm.
Yes, sir.
And the second thing is to isolate all the logarithms. Okay. So making sure there is no number in front of the logarithm, we're going to use this law of logarithm. log A raised to the power n base b is equal to n log A base b. You remember this property?
Yes, sir.
Okay. So we can rewrite the question as log 3y squared minus 10 base 4 is equal to log y minus
Y minus
all
1
squared
square.
base 4 plus 1 over 2. Is that okay?
Yeah.
Then the next thing to do is to isolate the logarithm. So I move one of the logarithms to the other side. So that's log 3y squared minus 10 base 4 minus log y minus 1 all squared base 4 equals 1 over 2. So with this one, because the bases are the same, we can divide the arguments. So this becomes log 3y squared minus 10 over y minus 1 all squared base 4. Are we good?
Yeah.
It equals 1 over 2. At this point, you can also use the converting the logarithm to indices. So we've got log a base b equal to x. This can be written as b raised to the power x equal to a. I think we've done this several times today.
Yeah.
So I can write this one as 4 raised to the power 1 over 2 is equal to 3y squared minus 10 over y minus 1 all squared. Okay?
Yeah.
So this is the normal quadratic equation to solve. So that is the same as writing 2 multiplying, and multiplying both sides by y minus 1 all squared is equal to 4 raised to the power 1 over 2 is 2, by the way. So 3
Yeah.
squared minus 10. Okay, so from here, we can expand and simplify. So 2y squared minus 2y plus 1,
Plus 1.
then 3y squared. Let me move the through everything over there since it's a quadratic. Are we good with this?
Yes, sir.
Okay, so expanding this will be 2y squared minus 4y plus 2 minus 3y plus 10 equals to 0. So cleaning up a little bit, I don't have space. Okay, so cleaning up a little bit, we should get this one to be negative. Wait, this y
It's
squared.
minus 3y square.
Yeah.
Yeah.
Okay, so this. Hold on a minute. Okay, sorry about that. This is going to be 2y squared minus 3y squared will be negative y squared. We get
Yeah.
then minus 4y plus 12 equals to 0. So that's y squared plus 4y minus 12 equals to 0. I actually don't like writing it this way. With negative in front of the quadratic term. I don't like that at all. Okay, so use the calculator to solve this quickly. Ideally, you're not supposed to use the calculator for this. This is a paper 1 question.
So
And
2 and minus 6.
so y is equal to 2 or y minus 2 and y plus 6 equals
Yeah.
0. So y equals to 2 and y equals negative 6. Yeah, we're told to find y. Yeah, then with this one, you have to be very careful. Let me take the answers over here. Let's take it to the top and see. So you could see that if you substitute y to be equal to negative 6 over here, you are going to get log so 2 log negative 6 minus 1, which is going to be equal to a math error or something. We get? Or if you like, you can basically use the calculator to do all the checking. So we write the question again on the calculator. So log to the base of 4 of 3y squared minus 10. Then I move the other one to the other side. I just leave the number. So minus 2 log to the base 4 of y minus 1 I'm going to substitute the values. If I substitute the value and it's correct, I should get the answer to be 1 over 2. The first value we got was what? I
2.
think 2. So y equals to 2. If the answer is correct, it's 0.5. Yeah, so that's correct. And the next value to substitute is negative 6. This is giving us math error. So that's not going to work for us because if you substitute the negative 6 over here, you end up getting 2 log negative 7. This is going to give us math error. So even though we've gotten 2 answers from our solution, we say that y equal to 6 is an invalid answer, or it will provide no solution to this. Or just describe it. Never describe it by saying that this will give you a math error. Math error is not really a word in math. So yeah, it's the calculator term of saying that what you are doing, the function you are doing can't be carried out within the settings of the calculator you are in. So we can say that therefore y is equal to, okay?
Yes, sir.
So far you don't find anything difficult about this. So this one.
So I think the first question that was a little bit confusing, but the rest, like, see, when the bases are like a little bit similar, it's easier to do.
Okay. So don't worry, keep solving. Hopefully maybe we'll meet up a question that would bring out your difficulty. So okay, so with this one, we were told what to do, and you have to be very careful because if you don't take care, you're going to write this one as y raised to the power 5. They are really going to trick you with this question, this part of the question. From the beginning, we were told that wherever you see log x base 3, we have to put y over there. So there's log
Yeah.
x base 3, I can put y over there, and there's log x base 3. But the problem with this one is that the x has got an exponent of 5. If you don't take care, you're going to treat this one as y raised to the power 5. That's what I was saying. So you have to be very careful with this one before doing the substitution. Make sure the log x base 3 is a little bit like kind of isolated in a way. Yeah, this still brings me to the fact that log x squared base anything, it's not the same as log x all squared. I think I made mention of this one. So
Yeah,
yeah.
you mentioned this.
Okay, so let's rewrite the question. We can write it as log, sorry, 3 brackets open, log x base 3 whole squared plus. Now apply the
5.
law of logarithm, 5 log x base 3 minus, this is 2 actually,
Yeah.
9 base 3 is 2. So we can now do the substitution. This gives you 3y squared plus 5y minus 2 equals 0. Use the calculator quickly. Let's solve this one then.
Then 1 over 3 and minus 2.
Okay, so 1 over
So
3.
y, yeah,
Okay, so
y minus
1
1.
over
Yeah.
3 and y equal to 2. Okay,
Yes.
okay. So from here, we should be able to do something about it. So I think you should be able to continue.
Is it?
I think you should be able to continue. We
Yes.
are finding x, so we can do the back substitution. Then we go. So the back substitution would be log
So x
x
equals
base
to
3
9.
equals 1 over 3. So x raised to the power, sorry, 3 raised to the power 1 over 3 equals to x. Then log x base 3 equals to 2. Then 3 raised to the power 2 equals to x. So we've got x to be equal to the cubic root of 3. Then x is equal to 9.
9. Yeah.
Okay. So both of them are positive, so we are good to go. We don't really need to do any
Yes.
testing.
So,
Well, yeah, can I continue?
yes, please.
Okay. Yeah, we have to express this one as a single logarithm. I've done most of the talking. Let's see if we can do this one as well.
Yes, sir. So I'm supposed to write 2 like 2 as a log, right?
Yes, please.
And that would be log 100.
Okay.
Okay, let me see what I did. I wrote 2 as a log. So I wrote log 100 plus log x cube minus log y.
Okay. But I'm not done. We're told to write it as a single logarithm.
Yeah, okay, I'm coming. I made a mistake. So the answer is log 100 x cube over y.
Okay, log 100 SQ or Y. Okay, so this is how I would have done it. Because we were told to write everything as a single logarithm, this is the same as writing 2 plus log x cubed minus log y. Then this is 2 plus log x cubed over y as the argument. But this 2 is not logarithm, and I know that log 1010 is 1. So I can say that is the same as writing 2 multiplying log 1010. After all, this won't be wrong because if you multiply any number by 1, you still get the same number. So this I would have done mine. So plus log x cubed over y. So from here, we can say that is the same as writing log 100, just like you rightly said, plus, because 10 squared is 100, log x cubed over y. So this will give you log 100 x cubed over y. Nice work. Okay, for 3 marks. You have to solve this equation. This is a quadratic equation. So solve this equation. So be fast about it.
So am I supposed to use the calculator as just one?
Yeah, use the calculator. Get the equation set up, then use the calculator. I'll move faster.
Say 1 over 3 and minus 3 over 2.
So x equals to 1 over 3.
Yeah.
X equals to,
Minus 3 over 2.
okay, negative 3 over 2. So, yeah. Anytime you're solving a question in math, or specifically add math, and you come across this word hence, they are basically telling you that you are supposed to use something in the previous question to solve this particular question. Is that okay?
Yes, sir.
You have to use something in the previous question to solve this particular question. Now, the question we are trying to solve is this one. We're going to first try to write it as this one. It's not compulsory though. There are other ways to solve it, but to be faster, we have to use something we've already solved to solve the question. Now, this question, unfortunately, the bases are not the same. This is base A and this is base 3. And I think there will be a swap of bases over here. I think I did make mention of swap of bases. So this change of base by a special one, if you want to swap the 2 positions, we say that this is the same as writing 1 over log. Then we swap the position of the 2 items. Okay?
Yes, sir.
Okay, so this thing can be written as 6 log 3 base A plus 7 minus 3 into brackets 1 over log 3 base A. Do you agree?
Yes, please.
So by comparison, you can see that it's the same as the question we solved.
Yeah.
Yeah, so the x is now replaced with 3 base log 3 base A. Then the x has been replaced with log 3 base A. So from there, we can say that therefore log 3 base A is equal to the answer you got in the previous question, which is 1 over 3. Then log 3 base A, and the answer we got in the previous question was negative 3 over 2. So we can apply the logarithm to exponential again. So a raised to the power 1 over 3 is equal to 3. then a raised to the power negative 3 over 2 is equal to 3. So yeah, we can get rid of this by cubing both sides. Do you agree?
Yeah.
So a is equal to 27. How do you think you can shake off the negative 3 over 2? There are lots of ways to do it.
A
Mm-hmm.
A squared open bracket 1 over. No. A minus 3. A raised to the power minus 3. All in bracket 1 over 2
Okay.
is equal to 3. Which will become e, e. The square root of A minus 3 is equal to 3.
Okay.
Um, and square both sides. Which come A minus 3 is equal to 9. So A raised to the power minus 3 is it the same as 1 over 3? A raised
Mm.
to the power.
It's the same as a raised to the power 1 over a raised to the power 3.
Uh, which will, the cube root of both sides. Oh. Honestly, I don't know what I'm
But
doing.
you're not wrong. So far you're not wrong.
Yeah.
It's just that you're
Okay.
taking too much time for this. Cubic root
Uh,
of 1 is 1, cubic root of a cube is a, and cubic root of 9 is cubic root of 9.
okay, so then so A minus 1. No.
So I can cross multiply. So 1 over 1 is equal to a cubic root of 9. Then divide both sides by cubic root of 9. Cubic root of 9. This is actually a waste of time. 1 over cubic root of 9. Or we can say that there's the same equation 9 raised to the power negative 1 over 3. Is that okay?
Yeah.
Okay, so that's waste of time. So I'm going to delete all of them. Okay, so that's how we go about this one. Actually, if you want to get rid of the exponent, that's what most people don't tell you. We tell you that if you've got square roots, so if I've got a raised to the power 1 over 2, that is the square root of a. If I want to get rid of this, what do I do? You
Square
square this
also.
one, right? Okay, so you square this one. So this will get rid of that. And if I've got, let's say, a squared, and I want to get rid of the square, what do I do?
Square root.
You take square root of this. So it's the same as writing raised to the power 1 over 2. So the general thing that people don't normally tell you is that when you want to get rid of the exponent, it's just the reciprocal of the exponents. So there's 1 over 2, right? So if you want to get rid of the 1 over 2, right, the reciprocal of 1 over 2 is equal to 2 over 1. So I take it to the power of 2 over 1. Okay?
Yeah.
So if I've got a raised to the power 1 over 3, and I want to shake this one away, I'm going to multiply everything by 3 over 1. The main thing is that when these two things multiply, you should get 1. So the reciprocal of the number. So if tomorrow you come across something like 4 raised to the power 7 over 2, and you want to shake this one off, we say that this raised to the power 2 over 7, the reciprocal of the number. Is that okay?
Yes, please.
Okay. So from here, we could have done that straight away. That's okay. We want to get rid of the exponent. So I need to take everyone to the power of the reciprocal of the number. So a raised to the power negative 3 over 2 is equal to 3. I'm going to take this one to the reciprocal of negative 3 over 2 is negative 2 over 3. So there's negative 2 over 3. Is that okay?
Yeah.
So this cancels out this and we get a raised to the power 1. And 3 raised to the power negative 2 over 3 is the same as writing 3 squared raised to the power negative 1 over 3. And there's the same as writing 9 raised to the power negative 1 over 3. If you realize that's what we got.
Yeah.
Yeah. So if you want to shake off something, please make sure you
make the reciprocal of the
Yes, yes.
exponent.
Okay. Okay. Can I continue?
Yes, sir.
Okay. Okay, so this application, we'll do the applications later. Do this in book week.
10 raised to the power 3 is equal to x. X is equal to 1000. So I should do which one?
All of them.
Okay.
Okay, so the first one is basically writing log in an exponential form. So what's the answer to the first one? That's the easiest over there.
1000.
Good, s equal to 1000 because this log x base 10 equal to 3. Then this and this. So 10 raised to the power 3 equal to x. Then x equals to 1000. Okay, so this one too, we've done a similar one.
So it's log 1000 a over b.
Log, yeah, you have to be careful about this. Yeah, log 1000 a over what?
Over b.
No, that is not correct. So this can be written as log a minus log b squared
Over b square, sorry.
plus log 1000. So log 1000 a. Okay, that is good. So log
Yes, b squared.
1000 a over b squared. Okay, so there's also a similar question. I think we've done this, so let's not waste the time. We good?
Yes, sir.
Okay. And this application, we'll do the applications later.
So I saw questions like p complement. Not in this one, like some
No,
people.
that is differentiation. You've not done
Oh,
that. You do that in two terms, calculus.
oh.
Well, we solved this one already too. That was the first question we solved. We solved this one too. Yeah, let's see if we can do this. We have to find the value of x and y.
Okay.
Sorry, x, y.
So xy is equal to 2 raised to the power 8.
Come again.
Say I'm coming. I'm coming. Say xy is equal to 4.
xy equals to 4. I don't know the answer, but let's see. The first thing is the change of base, and I told you that I advise, it's not compulsory though, to change to the smaller base.
Yeah.
So x raised 2 plus, this can be written as 2, or let me just write this one as log y squared base 4 equal to 8. We get?
Yeah.
So there's log x base 2 plus log y squared base 2 over log 4 base 2 equals to 8. So I did the change of base over here. And this can be written as log x base 2 plus log y squared base 2 over 2 equal to 8.
Yeah.
To give you, multiply everything by 2. So multiply this one by 2, multiply this one by 2, and multiply this one by 2. This will give you 2 log x base 2 plus log y squared base 2 equal to 16. Do you agree?
Yes.
And this can be written as log x squared base 2 plus log y squared base 2 equals to 16. And from here, because the logs are adding up, we need to multiply the arguments. So there's log x squared y squared base 2 equals to 16. Then
Yeah.
this is the same as writing. There are a lot of ways to continue from here. I can change to exponential, or I can manipulate it further. I can write this one as xy all squared base 2 equal to 16. Do you agree? Okay. I can also write this one as 2 log xy base 2 all equal to 16. Then divide everything by 2. Divide this one by 2. So giving me log xy base 2 equal to 8. Then xy is equal to 2. So 2 raised to the power 8 equal to xy. So you didn't get it correct.
So that was my first answer.
Yeah, but why did you change it?
Because it was like the working one, I did it some way and it was too short. So I wasn't
Yeah,
sure.
like it could be very, very short too, because I was explaining and doing a lot of things over here.
Yeah.
Yeah, so that's the answer.
I used
Mhm.
I used something you told me.
Okay, so
You
let
see
me,
the one that like you see the 2 log 4 y. You can make it log y square 4. So
yeah,
which can
so
be log y
let, let's
square 2
let
square.
me let me cancel this one. Are we good?
Yeah.
Okay, so let's use that one so that you know I'll be posting this one on YouTube. So this log y squared
2 square.
2 squared.
Yeah. Equal to 8. So I cancel this square.
You cancel the squared this way.
Yeah, that's what I did. Yes.
But
And
this
I go
no,
log
that was not what
x.
I taught you. That's not what I taught you. This
I was trying something. Log y 2 equal to 8. So then xy is That's log x y over here equals x is equal to 2.
Nice work. What I taught
That's
you was
a
the reverse of it.
um,
Nice work, nice work. I taught you this one. Log a raised to the power b. Then we've got a raised to the power, let's say m. The answer is going to be m over n. M over b.
yeah.
Yeah. And the reverse of this one, log let's say b raised to the power a, then log m raised to the power a is equal to log m b. Okay, so I didn't teach you this one. I taught you the reverse of that. Nice work with this. Okay,
I
can I
need to
continue?
review. Let's see.
Okay, so this indices to logarithm. Let's solve this one. How many questions more? Okay, yeah, let's solve this one. So we need to start breaking down things. Log this indices that would I'm very sure is going to involve logarithm later. So 2 raised to the power 2x plus 1 minus 2 raised to the power x plus 1 minus 2 raised to the power x plus 1 equals to 0. So we're going to substitute y equal to 2 raised to the power x. With that, we need to reverse the order of indices before we can do that. The 2 raised to the power 2x plus 1, we can say that this was once written as 2 raised to the power 2x multiplied by 2 raised to the power 1. Do you agree?
Yeah.
Because when the bases are the same and you're multiplying, we add the exponent. So minus, because of this negative, please, anytime you are going to reverse something with negative in front, I would advise you bring a squared bracket. Again, it's not compulsory, but it's something that would make your working easy. Is that okay?
Yes.
Okay, so um, from here, I can say that this was once written as 2 raised to the power x times 2 raised to the power 1 minus 2 raised to the power x plus 1 equals to 0. So this will be like me writing as 2 raised to the power x all squared times 2 raised to the power 1 is 2 minus 2 raised to the power x times 2 minus 2 raised to the power x plus 1 equals to 0. Assuming the question didn't tell you to do the change of what's the name, the substitution over here, you
Yeah.
still would have done the substitution. Remember what I told you? I was like, anytime you are doing math and you see that one thing is repeating itself severally, you can let it become a variable so that the work becomes a little bit easier. So in this case, I can say that let's y to be equal to 2 raised to the power x. So we're given that already. So this will give you y squared times 2, which is 2y squared, minus 2 times y will be 2y. Then this is y. Then this will be 1. So this will give you 2y squared minus 3y plus 1 equals 0. Then we solve the quadratic equation. So let's solve the quadratic equation. Use the calculator real quick.
Say 1 in half.
So y is equal to 1. So y minus 1 and 2y minus 1 equals to 0. So y
Yeah.
equals to 1 and y equals to 1 over 2. But y in itself was 2 raised to the power. So we've got 2 raised to the power x equals to 1 and 2 raised to the power x equals 1 over 2. So this one we are changing from logarithm to exponential. This one is easy. We can, let's use logarithm. We can actually use indices to solve the question. The answer is 0 and negative 1. But for the fun of it, let's use logarithm. Let's do the indices first. This is the same as writing 2 raised to the power x equals 2 raised to the power 0. And then 2 raised to the power x equals 2 raised to the power negative 1. So x equals to 0 and x equals to negative 1. Is that okay?
Yes, sir.
Yeah, but for the fun of it, let's use logarithm. So we need to convert this one to logarithm. The base is 2. So I can write this one as what? Log what?
Log 1 base 2.
So log 1 base 2 equals x. And this one I can write it as log
Half base 2.
equals to x. So log 1 is 0. So x equals to 0. And this is the same as writing log half base 2 is equals to -1 equal to
Yeah.
x. So x equals -1. Then x equals 0. Okay?
Yes.
Okay, great. So that is the B part. Question number 12. We solved a lot of questions today. Oh, we're almost done. Okay, so given that log xy base 9 equals to 5 over 2,
Yeah.
show that this can be written as that.
Um, so I have an idea, but I don't know.
Okay,
Yeah.
so let's do this together then. Looking at the a minute, I think
Okay.
my phone charger phone is messing up. It's messing up my computer. So. Okay, so I was saying that looking at the proof, the other part of the proof, one thing you can notice is that the bases of the logarithm over there are all to the base 3. And
Yeah.
the question we were given to start a proof with is in base 9. So the first thing we have to think about is to change the base from base 9 to base 3. Okay?
Yeah.
So start off this way and let's see.
So it's log xy. Has changed log 9xy to base 3.
Yeah.
Okay. Log xy over log 9. Put base 3. Put base 3 on both sides. So log xy base 3 over 2.
Okay, so log xy base 3 over log. Okay, so that's 2 over log 9 base
Yeah.
3 is 2. It's equals to 5 over 2. We good?
And then cross multiply.
So this will give you
Multiply both sides by
by
2.
2. So this will give you log xy base 3 equals to 5. Do you agree?
Yes.
But log xy, I can say that this was previously written as log x base 3 plus log y base 3 equals to 5. And that's the end of the proof.
Okay.
How we get?
Yeah.
Okay. Okay, so it wasn't that difficult.
Yeah.
So let's see if we can solve this one. We already know that log x. Okay. Let's solve this one together. Okay, so this one, logarithm involving simultaneous equation. The main thing you need to do is to try as much as possible to get rid of the logarithm that comes with a question. And also, there is a very big trick with a question over here.
The
Yeah, the
multiplication.
multiplication. They are expecting you to write it as log x plus y base 3. That's where you're going to go wrong. We get? So you have to be very careful. This is not, it's not the same as that. Log works with multiplication, addition to multiplication, not multiplication to addition. It's indices that works from multiplication to addition. Log works from addition to multiplication. We get?
Yes.
So they are expecting you to commit that error, but we are not going to fall for that. And also the question start with hence. And I did tell you today that anytime you come across this word, it means that there is something you have to use in the previous question to make this question easy for you. Now, the only thing I can see over here is that we're able to write log xy base 9 equals 5 over 2 as this one.
Yeah.
So in this question, I can replace everything of this one with this. Are we good?
Yes, yeah.
Okay. So by so doing, again, I told you that if you're solving a question and you keep saying one thing over and over and over again, there should be a representation of that. So in this case, this is what I can see over and over and over again. There's log x base 3 in the first equation. And in the second equation too, I've got log x base 3. And in this first equation, I've got log y base 3. And in the second equation too, I've got log y base 3. So I've got every right to make variable representation so that the work looks easy for me. So I can quickly say that let's say a equal to log x base 3. Or let me use m and n. So let m be equal to log x base 3 and n to be equal to log y base 3. Is that okay?
Yeah.
So if that's the case, then my first equation would be m plus n equals 5. And the second equation is going to be mn is equal to negative 6. Are we good?
Yeah.
So that's quadratic simultaneous equation, one of the first topics I taught you. So this equation 1 and this equation 2. We can make m the subjects. So if you make m the subject of equation 1, you get m to be equal to 5 minus n. Then you can put this into equation 2. So this will give you 5 minus
5 minus
n equals negative 6. So negative n squared plus 5n plus 6 equals to 0. And n squared minus 5n minus 6 equals to 0. Like I told you, I don't really like when the quadratic term is negative, so I normally do it this way. Yeah. So use the calculator, quickly to solve this question, and we go.
Okay. N squared minus 5. Say 6 and minus 1.
Okay, so n equals to 6.
N plus n minus 6
So n minus 6 and n
plus 1.
plus 1 equals to 0. So n equals to 6 and n equals to negative 1. So we can find the value of m. So when n equals to 6, m plus 6 equals to 5, which means that m is equal to negative 1. Then the first pair of answers, we've got m to be equal to negative 1 and n to be equal to 6. The next pair of answer will be with n equal to, it's basically the reverse. So this is 1 equal to 5. So m equal to 6. So this will give you m equal to 6, n equal to negative 1, because there's a product. Okay, we are not done. Remember, we made a variable representation. We said log x base 3 equal to m. So I take the first pair. So log x base 3 equals to negative 1. Then log y base 3 equal to 6. We can convert this one from logarithm to exponential. So that's going to be 3 raised to the power negative 1 x
equal to x.
So x equals to 1 over 3.
1 over 3.
Then again, we can convert that one to exponential. 3 raised to the power x equals to y. And I think this is much of a big number. So y is equal to 3 raised to the power 6 would be 729. 729. So the reverse is going to be true, but let's do it anyway. So there's going to be log x base 3 equals to 6 and log y base 3 equals to negative 1. So we've got x to be equal to, so 3 raised to the power 6 equal to x, where x is equal to 729. Then we've got 3 raised to the power -1 equal to y, where y is equal to 1 over 3. So these are the answers to the question. Okay?
Yes.
Yeah, there were a lot of tricks in the question. A lot of people would have fallen victim to this, the multiplication over here, and they will change it into addition. But before you fall victim to it, you should know that logarithm changes addition and subtraction to multiplication and division. And indices changes multiplication and division into addition and subtraction. Can I continue?
Yes, please.
Yeah. So I think there's a during the last question. So show that log 4 base 9 equals to log 3 base 2. So this change of base again. So this will be log 4 over log 9, and the base over here is 3. So let me use base 3 over here. So this is equal to log 2 base 3. So that's the same as writing log 4 base 3 over 2 equals to 2 base 3. Are we good?
Yeah.
And log 4 base 3 is the same as writing log 2 squared base 3 equals to over 2 log 2 base 3. And this can be written as 2 log 2 base 3 over 2 equal to log 2 base 3. This 2 can then cancel out this 2. So the answer gives you log 2 base 3 equals to log 2 base 3. And that's the proof. Okay?
Yes, yes.
So again, the word hence is used, which means that there is something in the previous question we need to use for this question. So in the previous question, we saw log 4 base 9 to be equal to log 2 base 3. So it means that I can replace this one with log 2 base 3.
Log 2 base 3.
So plus log x base 3 equals to 3. So the bases are the same. So I can write this one as log 2x base 3 equal to 3. Then I can apply the logarithm to exponential. So 3 raised to the power 3 equal to 2. Okay?
Yeah.
And there's 27 equal to 2x, and x is equal to 27 over 2. And that answers the question. I'm pretty fast because I know you can get a file and solve it all by yourself again. And also, this is recorded as well. And I'm not teaching you as well. We are solving questions. I've taught you all this already. You get?
Yes, sir.
Okay. So there's the last set of questions. If we finish up with this, we go with the application. Then I know I'm done with this paper. Then we do the paper 2 by yourself. So given that log x base a equals b, log y base a equals q. Yeah, this one came in the this one came in the amount. Did you see?
Which mock?
Your senior mock. Yeah.
I didn't go through their paper.
Okay. So this one can be written as log a base a plus log x base a plus log y squared base a. Are we good with this?
Yeah.
Okay.
So doesn't the square affect ax and y?
No. The square is on the y, not the.
No. Okay.
If it were to be on everything, they would have placed the brackets over here.
Oh.
We good?
Yeah.
Okay. So log a base a is 1.
Yeah.
Log x base a we're given as p, and this can be written as 2 log y base a. So this can be written as 2q. Okay?
Yeah.
Okay, so with that idea, see if you can solve the other one by yourself.
Okay. So there's log x cube base a minus minus log a base a plus log y base a.
Okay, so this was a mistake I was suspecting, and you did it too. I told you that anytime you deal with minus, make sure you bring a
All
bracket
in bracket.
around it.
Yeah.
Is that okay?
Yes.
Is that okay?
Yes, please.
So make sure you bring a bracket around it. So I was expecting you to give me this one, log x cubed base a minus log ay base a. Then from here, we know that we're going to expand this one, so we'd have to bring the bracket around it, and we get to this one. So
Okay.
this can be written as 3 log x base a minus 1 plus log y base a. So this equals to log x base a was given as p. So there's 3p minus 1, and log y
Plus
base a
q.
was given as q. So there's the answer, or you can expand it. 3p minus 1 minus q. There's also the answer. We get?
Yeah.
And the last one will be the basis of the logarithm given to the question are all in a. But in this particular one, they are in x. So we have to do swap of bases.
So it's in x and y.
Yeah, x and y. We have to do swap of bases. So swap of bases would be 1 over log y base, sorry, x base a
X base a.
plus 1 over log y base a. So x base a is p, so that's 1 over p plus 1 over q. So there's the answer. If you get over excited, you can find the LCM and you go. But it's 1 mark, so there is no need to do that.
Mm.
You get?
Yeah.
Are you sure?
Yes.
Okay. Now, the last one, we've done a similar one, so try to do this by yourself. Again, there is minus. I would advise you to do this in squared brackets so that you don't get yourself confused. So, anytime you deal
That
with
is
square
it.
brackets, you have to bring a squared bracket around it, okay?
Okay.
Yeah,
See.
I'll swap the Wednesday class with that of your brother's class, okay? So instead of meeting from 7 to 8:30, you meet from 8:30 to 10. He has got a class from 8 to 10.
Okay. Sure.
Okay?
Yes, sir.
Okay. Okay, so we don't really have much time. Let's see. We've got 3 raised to the power x minus 3 raised to the power 1 times 3 raised to the power 2x. Did you catch that?
Yes.
Plus 4 equals to 0. This can be written as 3 raised to the power x minus 3 times 3 raised to the power x all raised to the power 2.
That's where the thing came from.
Oh, okay. That was the problem, eh?
Yeah.
So this can be written as m minus 3 times m squared plus 4 equals to 0. So m minus 3m squared plus 4 equals to 0. So 3m squared minus m minus 4 equals to 0. And we solve for m.
Say 4/3 and minus 1.
Okay. 4/3.
So that means 3x minus 4.
That again?
It's 3x minus 4. Yeah.
So m equals to 4/3 and m equals to -1. So we go back 3 raised to the power x equals 4/3. Then 3 raised to the power x equals -1. No, this is not possible. Anyway, let's see. We convert this one to logarithm. This will be log 4/3 base 3 equals to x. And this log -1 base 3 equals to x. This is not possible. Or no solution. Then we can type this on the calculator. Log 4/3 base 3. That will give you the value of x. We get?
Yes.
Okay.
Get 0.261.
0.261. So you can go to this website, My Study Compass, for the paper. It's actually a very good website. Yeah, for topical. So yeah, we solved all the questions over there. This was solved already. Then this one hasn't been solved. That's application. Application. This solved. Application. And application. We don't really have much time to go through the application, but it says that success doesn't come from what you do occasionally, but what you do consistently. So you would go through the paper 2 aspects of this, and go through the paper 2 aspects of that. Let me see if I can get you the paper 2. If you go to the website, the paper 2 is there. Solve the paper 2. That's what we'll be doing. That's what we'll be doing the next time we meet. That will be on Wednesday. And also, I'll post a video today. And if I do, try to share it to your friends too. Okay, at least. So that those that are not getting any opportunity to have a class, they will learn something. Okay, so you can attempt the paper 2. Can leave out all the application questions. And once you are very good with the normal one, the application is not much difficult. I just have to tell you some technicalities when you solving questions of that nature. It's not difficult at all. It's actually very easy. So it's not a big deal. So you go through the paper 2. It's not much. How many questions? 19 questions. Yeah, it's not much. We'll solve all the 19 questions tomorrow, Wednesday. Then yeah, that'll be that. And we'll start with the curve sketching, then we do the straight lines. That'll be all for today's class. Any question before we go?
Yes. And said simultaneous equations are in logarithms, right?
Yeah, it's actually in everything, you know. That's why it was the first topic we actually taught you in school. It's in everything. The quadratic simultaneous equation is in everything. It can be mentioned like to almost any topic at all.
Oh,
Yeah. Okay, so you just try your hands on the paper too. Go to the website, My Study Compass. Have you written it down?
yes, please.
Yeah, go to My Study Compass and work out the paper two. Okay, you can also take the paper one as well. Then you resolve the question to see if you really understood what was going on.
All right.
Okay, bye bye for now.
Say bye.
Yeah, bye.